Hello everyone, myself Dr. Vijay Kumar Vishwakarma, and today I will explain how to do the MD simulation of small molecules using Gromacs. Here there are numerous methods to simulate the MD simulation using Gromacs for a small molecule. Basically, there are two types of commands. You can use X to X to top command. Okay. By this command, you can generate the topology or ITP file for your small molecule. But for this, you have a basic knowledge of force field parameters. If you do not have a basic knowledge, you can use external server to generate that ITP file for your small molecule. So in this video lecture, actually, I am going to explain the use of Swiss param server to generate the small molecule ITP file and process it for MD simulation. The basic procedure for the MD simulation is remain same as in the all my video lecture, like a simple molecule for protein and ligand or protein. So the first step is generating topology. Second step, use this topology to fit into the box, and this will be the different type of boxes like cubic, tetrahedron, rhombic. As per your choice, you can use it. Now the next step will be solvating by using water model TIP 3P, TIP 4P, etc., or simple SVCE model. Now replacing the water by ions, ionization. If your molecule have some charges and if you want to simulate with a specific type of ions, now we go to the minimization and ensemble hypothesis like NVT and NPT, and finally we go for the production MD. And in last step will be the analysis of your MD simulation. This is the basic procedures. So I'm going to start first from generating the topology file using the Swiss firm web server. Here in my folder, this is my simple molecule, and it is basically the paracetamol molecule. So first of all, I am showing the structure of this molecule. Just see, this is the basic benzene ring. and this is the OH group. This is the nitrogen and C double bond O and NH3. So basically this is the acetaminophen or paracetamol. First of all, we have to save this file in a PDB format. So I am just saving it into PDB to the desired location, that is the my C drive and MD folder. Okay, so this is will be the lig dot PDB. So you just seeing here that there will be the two file. First is mol2 file format and second is PDB. Now I'm going to create the topology using the Swiss param web server. So first of all, just type here Swiss param and open the website. Now we have to submit our molecule. So choose here. Before submitting your molecule, you have to take care of few things. First of all, your molecule must be in mol2 file format, and all hydrogen bonds should be in 3D coordinate. Okay, so here I am using the my mol2 file. Now just press the submit button and wait for a while. For that moment, I am pausing my video. Now once the Swiss firm have done their job, so you get a link to download your link.zip file. Just download it. Just see here, my download is completed and I'm going to browse inside the folder. So this is the download. So just see here, your download is here, but due to some technical issue, it is not showing the exact file format. So first of all, you can rename it. That is the lig dot tar. And now you are able to extract this one. Okay, so just right click on it and extract the files. So these are the parameter files. So just copy these all files, Control A, C, and paste it into your desired folder. From here, I want to run my MD simulation. Okay. So these are the all files where the main file is your leak.itp, that is the your topology file generated by the Swiss Param web server. So you can use for the further calculation. Now, once I have generated these files, go to your basic installation and open Ubuntu. Now, here you have to first of all export your Gromacs by using source opt Gromacs bin gmx rc. Your location may be different because most of the time, as per the website of Gromacs, this will be the user local Gromacs. Since I install the Gromacs at custom position for a particular use, so I am using my own location. You may choose your own location to export the Gromacs. Now my Gromacs is running. I can just uh, examine it by typing GMX. So you can see that the Gromacs is running. Now you have to go for the basic procedure, that is protein in water simulation. So I recommend the use the basic procedure explained by the Lemkul lab, and that is the mdtutorial.com. First of all, we have to go for the topology section. So since we have created a topology, so don't worry. But for a custom simulation, we have used a topol.taf file, and that can be generated by using the help of your previous MD simulation. So I am going to use one of the my previous MD simulation file, from where I am going to retrieve my topology file. That will be the this one. Just copy and paste this into here. Rename it to topol.taf, and now the open with the notepad. So just delete these parameters because this is not our parameters. Now our molecule is not a GRA, so I am using here lig. Our molecule is renamed as a lig. So replace are the words LIG with lig. Now we have to include the topology file, that is the our lig.itp. Okay, and this is the force field parameter file. So we have to also download the force field parameter file. Now just copy these lines, and you can, by manual typing these lines, you can also create the topol.taf file for your molecule. So don't worry, or you can use these lines by copy and paste from your previous simulation of topol.taf file. Now here I am going to show one thing, that we also have the charm force field parameter file in our working directory. So I'm going to download this one. Now just save it, and this is our ready topol.taf file. Now go for the manual search and just type here charm force field download. So we have to download the charm force field for our Gromacs. Just click on this website, that is the charm force field, charm.org. And now click for the charm 36 file for Gromacs. You find that there are two files. These are the recent one. So we have to download this one. Okay. This time I think the website is not running particularly. So I am going to use my previous downloaded files. Okay. website is not running because its logo is not properly came. So I think something error, but I have a downloaded force field parameter file. So you can easily download this file because I many times I have downloaded it. So there is no issue with the file, but why today it is not downloading? Because due to the slow running of server. Where is charm? Okay, this is the downloaded. You can see here in my download, this is downloaded 2 times. Okay, so there is no problem. You can download by retry after some times. Just copy this and paste this into our desired folder of the working directory. Just here, just paste it and now extract it. You can simply extract it by right clicking in window or using tar command in Ubuntu. So I simply extracted this, but this contains a folder inside a folder. So just copy all the files and cut and paste in the only one folder, that is the this one. Okay, now the this additional folder you can delete it or remain as it is. So here I am deleting it. Now what I basically changes here, I extracted these files in these folders. So this folder is contains the force field parameter files for the amino acid etc. Mainly the file which I am going to use is forcefield.itp. This one is iron.itp. So these are the parameter files which will be used by the softwares during the course of simulation. Now, once we have done it, we have to go for the basic procedure. So we have created this all. So just see, you can copy and paste these lines in a plain text file, and you can also create their own topology file. These are the parameters. So just I have created from the previous used topology file. You can also create, or you can copy paste these lines. Simply these lines, you can take a screenshot of these. Okay, so I am going to next step. Next step is to create a periodic boundary condition by using edit conf. So I am going to use this command. That will be the periodic this command create a periodic boundary condition for our molecule. Just see here. Now paste this command in terminal and edit as per your use. Since I'm going to use my own custom molecule, so here I am going to use the okay. I do not have created leak.grow file. So first of all, we have to create the lig.grow file. Here lig.grow file is not created. So we can create using this command also. Gmx edit conf lig.pdb o dash o lig.grow. That's all. Okay. In command line option, there is a error. Lig.pdb does not exist or not accessible. The file could not be okay. We have to change the directory because we are not in working directory. So this is the basic error. So I am going to change my directory cd mnt c enter. Now we have to go in my working directory cd md. Now we are inside the directory. Just type here ls and see these are the created files. These are the force field file and etc. Now our file now my file that is lig.pdb is inside the working directory. So I can use the previous command gmx edit con dash f lig.pdb dash o lig.grow. Now press enter. So just see here, Gromacs remind you. This means your command runs successfully. Now you can go inside the folder and check whether the lig.grow file is generated. So you can see here that is the lig.grow file is generated. This is the coordinate file and it will be processed during the MD simulation. So now we have to copy this command gmx edit conf, just paste it here in terminal. Okay, this is copied one. So we have to copy again and we have to paste it here. Now adjust the command as per your need. I just want to generate new box start grow. I want to use lig.grow file. So rename it lig.grow. This dash C option is tell us that the molecule will be inside the center of box. The box will be the dimension of 1 by 1 from the molecule and box type will be cubic. You can use dodecahedron, rhombic, etc. as per your need. Now just press enter. So you see here that the box of the following dimension have been generated by the Gromacs. I can check it manually by using virtual molecular dynamics simulation software. This is the VMD. So open VMD and load the new box.grow file. Just go to the new molecule, browse and load. This will be the new box.grow file generated by the previous command. Just load it and you can see here that your molecule is here. Just go to console and type PBC box. So VMD visualize you that you have created a box. So I'm going to maximize. Just see, this is the box created by gmx edit conf command and our molecule is inside the box and approximately absolutely at center, not approximately. So this will be fine. Now we have to solvate this box. Just go for the next command, copy and paste it here. So I want to update my topology file. I want to generate sol.grow file and basic SPC 216 water model. Okay, this is my input file new box dot grow, which is previously generated by the previous command gmx edit conf, and now I finally want to write the changes in the my topology file. Just adjust this command and press enter. Oh, I think everything is okay. So we have to go again to VMD and visualize the changes. Now this time our file is sol.grow, so we have to go and upload this file. So clearly you can clearly see that our box is solvated by water molecule and our molecule is inside the box approximately at the center. So everything is going fine. So we move towards the next command. So we can one thing we can also check in the updation of topology file. Just go inside the folder and open topol.top with notepad. So just see here that the our solvent molecule number 807 were added to the link. So everything is working fine. Now just cut it and go for the next command, that is adding ions. Before adding ions, we have to create the ions.mdv file. So we have to click here and copy these parameters. Just copy and make a new file and save in that file. So I am going to rename this file and make it ions.mdp. Just rename the file extension must be mdp. So this will be the ions.mdp. Now just press OK, edit with notepad and delete all lines and paste your ions.mdp parameters. So, for a small molecule, we can use particle mesh eval type instead of Coulombic type, because in some types I find that the suggestion of the software is this one. So as per your knowledge, you can change it. But here I am going to use this default method. So just save it. Our ions.mdp is ready. Now just close it and minimize it. Now move towards the next command and copy the command and paste on terminal. So we have to pass, this is Grom module. So we have to pass to the Grom module gmx Grom ions.mdp. Once again, we have to change the input file, that is our input file is sol.grow. And now we want to write the changes into pol.top, generating the ions.tpr file. Now press enter. Okay. So you see here that everything is going fine. Now I am going to pass with the genuine command. Just copy it and paste it in terminal. Now modify this command as per your use. Suppose if you want to use a particular concentration, you can set it in place of neutral. Now here, if your molecule has some charges, you can replace the water molecule by chloride ion, that is Cl. This is the negative ion name. Na is the sodium metal, that is positive ion name. You can also use calcium. Calcium here you have used to Ca. Now I want to generate ions.grow file. So I'm going to rename it out. Dash o means output file. That is, we are passing our genin command over the ions.tpr file. So I modified this command as per my need. Okay, now press enter. So everything is going fine. Now we have to check whether the ions were added or not. Since I think my molecule, that is the uh, paracetamol, do not have any charges, so I think there will be no any extra ion added instead of water. So just check it here. No. So no any ions were added instead of water. So if your molecule have charges, you find that some plus ions and minus ion will be added, and their number will be also given here. Now we do not have to, don't worry, we do not have to worry much. Next command is minimization. We have to go towards the next command and pass this from minim.mdp. Oh, so just click here this link and save the minim.mdp file. Just copy these parameters and now create a new file, that is minim.mdp. So I can use ions.mdp, just copy it and paste it and rename it. This will be the best option. minim.mdp. Now open and replace all the content inside the copied content. Okay, sorry. Again, copy this content and paste in minim.mdp. So you just see here, that is the title of the file will be minim.mdp. Just save it and quit it. Now we have created this minim.mdp file. Now we have to pass through the gromp command. Just copy this command and paste in terminal. Now we have to change these parameters of input lines because we are using as per our need. So I think everything is fine. Now click enter. Just wait. Okay. So I think everything is fine. Without any error, we have completed, successfully completed this command. So we have to go for the energy minimization. Now we can minimize this one. So finally, we have minimizes the energy. And since this is a small molecule, so this takes approximately least time to compute. As per the number of atoms increases in our system, it will take much more time to minimize the system. So as per the number of atoms, our work is done. Now I am going towards the next command, that is the equilibration. Before going to equilibration, if you want to analysis the potential energy plot, you can also use this command. So just copy this command and paste in terminal to see how the potential energy of system behaving at this stage. So just paste it here and press enter. Now we have to choose potential. So potential is listed here at 10. You can also take pressure, etc. as per the available options. Now I am going to type here 10 and 0. Oh, sorry. 10 space 0. Now press enter. So we are able to generate the potential energy graph, that is the average potential energy value, this one. So I'm going to visualize this potential energy graph. This is the potential energy graph. Since in window we are unable to plot the XVZ file using XM Grace, so here I am going to use the Excel to show this one. Now open potential.xvz customly in Excel. Go to your working directory and browse for the file potential.xvz. Okay, now open it and just click next. Now we have to choose for the separation of the 2 points where we want to put it in graph. So we have to choose this one, separate these two values. Now next and finish. So we have these two parameters in XY direction. Now we can clearly draw the plot. Just select, go to insert and scatter. Now this is our potential energy plot. Since potential energy, as the system is going the minimization, potential energy successively decreases, means our minimization is successful. Now just quit it, don't say, and leave it blank. Now we have to move towards the next command. Next command is equilibration, and first is NVT equilibration. So just copy the parameters for NVT from here, Control A, Control C, and create a file named nvt.mdp. Now here we have to make some changes. So first of all, I am duplicating the copy, just copy it and paste it. So we have created a file and now rename it, that its name will be nvt, nvt.mdp. Now open with text editor. Okay, delete all content. Now just copy all the parameters again and paste it on here. Okay, so first of all we have to clear that we are not going to simulate any protein, and our model is not based on protein in water, and there is not a two system. So protein and non-protein is not a part of our system. So we have to change TC groups, otherwise you get the error. So we have to write here system. Now delete these parameters for non-system ions, because we are not going to simulate for other. Okay, we are going to simulate for system as a whole. So there will be only one parameter in TC group and TC tau couplings. Okay, so just save it, rest is fine. You can also rename it the title flag, that will be the NVT equilibration. Now just save it and close it. Your file is ready. Now you move towards to pass through the ground module. Just copy this command and paste in terminal. Oh, sorry. Again, copy this command and paste in terminal. So I think we adjusted all the name and parameters. So don't I think no need to change anything. Just press enter and wait. If any error will come, I will explain how to remove it. So it says fatal error, too many warning, but these warning are not specific. So we cannot remove this warning specifically. So we have to use this option, and this option ask me to a integer number. Since our warning is 1, so we can use it with a flag of 1. So just I add here there's max warn space 1, and now press enter. Just wait. So I think everything is fine. So we can go for the next step, that is the production sorry, equilibration and VT. Okay, when you're going to run this MD run command, I always suggest you to add dash V flag, because with the help of this verbose flag we were able to localize the time to complete this command. So just press enter. Just see here, it is showing that the clock time, and within the remaining clock time it will completed. So this is the time. If I do not use the dash V flag, this it is not showing, it not show the time to complete the command. So just wait, I am going to pause. So finally we have completed successfully this command. Now we have to go towards the pressure equilibration, before which if you want to analysis the temperature variance, so you can use this command. Just copy and paste in terminal. Just enter. Now our temperature is at 15. So here we have to choose 15 space 0. So this is our average temperature value, 299.87 during the course of simulation of 1ns. No, so we have to go towards the next command. And similarly, as I explained, in case of potential graph, you can also graph this. You can also produce this graph using Excel. Now the equilibration. So we have to use npt.mdp file. So parameters of this file are given here. Just copy. Okay, and now create a npt.mdp file. So I am just going to copy and paste this file and rename it. That will be the npt.mdp. So rename it at npt. Now open npt notepad, delete all the parameters, just paste these copied parameters to this file. Now we again have to change the TC group parameters, because if you do not change this, you get a error. So just write here system and delete the second parameter and save it. Now close it. Copy this command and and paste in terminal. So I think everything is fine with the command. So just press enter. So the same error like the NPT. So you can use here dash max one because error is not so specific. So you can use this option. Now press enter. So everything is fine. So we have to go towards the second equilibration, that is the NPT. Just paste here and add the verbose. So it take approximately 5 minutes to complete. So just wait. I am going to pause the video, and after completion, I will be live. Well, the command is completed successfully. So we go for the analysis of pressure. So similarly, you can also plot using this in Excel. So we have to copy this command and paste in terminal. Now press enter. Choose the pressure. Oh, oh, pressure is at 17. So just type here 17 space 0 and press enter. Now the average pressure is given here. Similarly, you can also plot the pressure.xpg with the help of Excel. Now I'm going to show the production MD. If you also want to plot the density plot, you can also use this command. Just copy and paste. If thing is going smoothly, so you can analyze too many parameters. I think in my simulation the things are going very usual. So I think there will be no issue with the analysis part. What is this density? So density. What is the number of density? Density 24 0. 24 24 23. In my case 23 because my version is updated. So 23 0 and just enter. So average density of the molecule is this one. Now move towards production MD, and this is the last step of MD simulation. Before going to produce MD, we have to md.mdp. These are the parameters file. So before going to create this file, I am just want to make a file that is the md.mdp. So just copy any MDP file and paste here and rename it md.mdp. Rename, that is md.mdp. Open with notepad, delete all content and copy these all content and paste on that file to create the md.mdp file. So what is inside this file? What is the necessary changes? Uh, you can edit title, production MD. Okay. You can change number of steps, as in many videos I have told how to count the steps. You simply use this much value is equal to 1 and ns. So by using calculator you can change, but this is a tutorial video, so I am not going to simulate for a more number of nanoseconds. But what are the necessary changes in the file and parameters I'm going to explain here. Just here you have to write system Otherwise, we'll not able to simulate your molecule. So just delete it now. Just delete it now. Just delete it because we have only one system. Okay, so just delete it and save it and quit it from this one. So we are ready with the md.mdp file. Just copy this command and paste in terminal. Everything is fine. If you want to change this file md0_1, so you can change it, otherwise no need to change it. Just press enter. Let us see whether any error, because sometimes Grom say error. Okay, so there is a error, and that is the molecule name. Okay, so let us see how to remove this error. Okay, this is the basic error. I think this is the typographical error. Instead of system, I type here system. So just correct it, system, and save it and rerun the command. Okay, so we have to again rerun the command. Now just go. Okay, so everything is fine. Now we have to move towards the next command, that is the md run. Just said here the verbose dash b option. Now press enter. And okay, today is 22 and this will be finished 22 to, okay, this will approximately take 1 hours. So I'm going to pause my video, and after the completion of this command I will be live, or after some time. So let us see. So finally the MD simulation, means production MD, completed successfully. So I'm going to explain how to analyze the result. First of all, we have to convert the trajectory. So just copy these commands and paste in terminal. Now press enter. So here we working only with the system. Just like select one for protein. Just see here what you want to put in center in this command. Basically, due to the course of MD simulation, our molecule will be displaced from the mean position. So we have want to center the position. So just like we are analyzing for the protein here and centered with respect to system, but in my case we are simulated for the system. So you can center the lig with respect to system. So you can type here 2 space 0 enter. Now the ligand is centered. Now I am going to analyze the root mean square deviation RMST value. So just copy this command and paste in terminal. Now, what you want to analyze, just like in the command here, if you, in case of protein, we analyzing the RMST of backbone because backbone is the major component and which does not mainly change during the MD simulation. Only small fluctuations or deviations can be reported in backbone. That's why we are choosing the backbone. So in my case, we are analyzing for the lig. So we have to select the lig option. Here, the lig is at 2. If you type 4 as per the tutorial, you getting only for solvent. So this is not a good option. So choose here 2. So just type here 2 for lig and press enter. Again 2 for lig and press enter. Now our RMST graph is ready. Just go inside the folder and first of all locate the RMST. This is the rmst.xvg. Now you can analyze by plotting in Excel. Just take a look how this is looking. So open the file by browsing it. Okay, now I open the file. There is some necessary changes, so I think this can be done by seeing the values. Just see here and adjust the separation point. We want to separate this and this, so these 2 points can be separated. Now the next and finish. So these are the two parameters RMST points. Okay, this is only for 1NS. Now go to insert and charts and scatter. Now this is the RMST, and average RMST value is lie in the range of approximately 0.03 nanometers. So as per the system and uh, other parameters, your RMST value may be lower or may be higher. It depends on your simulation, method of simulation, and settings, like uh, which type of ingredient, temperature, pressure, equilibration you are using, and which type of thermostat you are using, depending on this value. But the in this graph, the fluctuation is less, or deviation is less, so we can say that RMST value is quite good. Now similarly, you can also compute the radius of gyration and other parameters, but here you cannot able to calculate the number of hydrogen bond because this is not a two system. So this is all about the MD simulation. More analysis can be found on the different web pages and research paper regarding to your need. So I think this is a enough for the MD2 simulation of the small molecules. So you can use it and analyze your small molecule by MD simulation. So next tutorial will be based on named, how to perform the named MD simulation. So thank you for watching this. Have a nice day.